discussion about systems of linear equations and how mass balances relate to them. And so here we've got an example problem. We're going to start with example problem 1. So it tells us we have a 150 kilogram batch of syrup. It contains 4.5% sugar, 95.5% water. The syrup is boiled. We add some other sugar into it, and we result with a syrup that is 125 kilograms. That's 8.10% sugar, and it wants to know how much water was boiled off and how much sugar was added. So let's set this problem up. Okay, so we want to take what's given in the problem and turn it into a nice little picture where we can see what's going on. So first we just created what I call the magic syrup box. It's just whatever process is going on there, whatever piece of equipment is needed to do that. Like I said, if you want to get fancy, you can start drawing on things as tanks or boilers and those sorts of things. But essentially, like I said, I'm just going to call it some magic box that does whatever we need it to do. And so, again, if we recall from the question, it says 150 kilogram batch of syrup contains 4.5% sugar and 95.5% water. So that's what our syrup is starting with. So I just started with stream A. It's coming in. It's our starting syrup. We know it's 150 kilograms, and we know its composition is this. The syrup is boiled, and other sugar is added. So we know that there's some amount of boil off, and the boil off is all going to be water. So what boils away is some amount B that I don't know right now, but I know that that stream's 100% water. I dumped some sugar in there, so I don't know what that amount is, but I do know that it's also 100% water. And then in the end, I can get that part D, the end syrup, is 125 kilograms, and that is 8.10% sugar. So it wants to know how much water was boiled off, so B, and how much sugar was added, C. So I can get those by setting up mass balances. So again, just as a reminder, what I'm trying to find are B and C, the amounts of these two streams. All right, so my tools for figuring this out is first is using the mass balance. And so I'm going to do an overall mass balance. And remember, my law of conservation of mass tells me that N is going to equal out. So which streams are going in? I know that A is going in, and C is going in, has to equal what streams are coming out. Well, B is coming out, and D is coming out. And I spaced those out a little bit because as we do the other balances, we're going to put in some more factors, and I wanted to leave space to where everything's still lined up. Remember, in addition to the overall mass balance, I can also write balances for each of the components. So I can write a balance on the sugar and a balance on the water. So let's start by doing the sugar one. So for the sugar balance, I can get that 4.5% times stream A plus 100% of stream C is 0% because there's no sugar in the boil off. So 0 times B plus 8.1% times stream D. The other thing I could do that I haven't done yet is go ahead and put in the other things that I do know, which are the values of A and D. So I'm going to do that up above in the overall mass balance and apply that to the sugar balance to simplify those two equations. So I can put in the 150 for A and the 125 for D. And then I could also simplify that down by subtracting 125 from each side, and I can know that 25 plus C is going to have to equal B. But again, these are simplifications that I don't necessarily have to deal with. I can do the same thing with the sugar balance. I can plug in the 150 for A. This is still just 1 times C. The B part is going to go away because I have 0 times B. And I can put in the 125 kilograms for stream D. And now, if I simplify, you'll actually see that I could get to solve for C without even having to involve the other balance. So by simplifying, I get that there's 6.75 kilograms of sugar in stream A, plus whatever, all of the amount of C ends up with 10.125 kilograms of sugar on the end. So again, I can actually solve for C immediately by just doing the subtraction, and I get that I would get that C equals 3.375 kilograms, or if I want to put it in or with the correct number of sig figs, the others seem to have 3 significant digits, so I would round to 3.38 kilograms. So now actually I have enough information now, since I know what C is. I could just use my overall mass balance equation, plug that in for C, and get what B is. But because I want to work on learning how to do the equations, I'm going to go ahead and work out the water balance. Okay, so to check the water balance, 95.5% of what's in A, so 0.955 A, plus there's no water in C, that's just sugar getting dumped in. B is all water, the boil off, so we have 100%, so just 1 times B. And then again, it doesn't explicitly tell me that D, how much water is in D, but I know D is just sugar and water, so it's whatever 100% minus the 8.1%, so I get that it's 91.9% water in part D, so 0.919 is what I multiply by D. So again, I have that for my water balance. I can put in, for now I'm just going to put in that new A and D to start with, although technically I know C. So again, just putting in the 150 for A, the 125 for D. Doesn't matter that I know C, because C gets multiplied by 0 and goes away in this case. So let's simplify. So I get that there are 143.25 kilograms of water coming in that was all in stream A. It has to equal whatever was in B, plus there's 114.875 kilograms of water left in our syrup at the end that's in D. So again, I'm in a fortunate situation where the equations actually don't interact, and I don't have to really solve a system of equations. I just have to cancel them out and get the value. So I can simply subtract the 114 kilogram, 0.875 kilograms from both sides, and I can get that B is 28.375 kilograms, or again, if I'm rounding to 3 significant figures, it'd be 28.4 kilograms. So that would give me the amount that came out there, but I never really used the overall mass balance. And so the overall mass balance would still be a good way to check my answer and make sure everything is right. So as I'm checking my overall, I'm almost barely enough to show the page, I had 150 in A, plus the 3.375 of sugar added, has to equal the boil off, which was the 28.375, which was in B. And notice I used the exact amount to try to test it here. I could use the rounded version, and if you use rounded versions, expect that you're going to get a little bit of error on the end just because of the rounding. If I use the 3.38 and the 2.4, I'll probably be off by a couple of hundredths or maybe tenths because of that. And I used the wrong number here. This would be the 125 kilograms that was in D. So I add all those things together, and we should get the same thing on both sides. And we do. We get 153.75 kilograms in equals 103.75 kilograms going out, which is a good sign that our equations have worked. So that one we didn't even really have to employ systems of equations, but that is a good example of how you can set up and use a mass balance equation.